In the last video, we studied about heat capacity and specific heat. And today we're going to see how we can measure the specific heat of a certain sample. So let's say we take a sample of known mass and temperature and we place it in a vessel that contains water. We know the mass of the water and its temperature. And by measuring the temperature of the water after equilibrium has been reached, we can calculate the specific heat of that sample. Now this technique is called calorimetry, and the device that's used in calorimetry is called a calorimeter. So actually let's draw a sample here. So here we have a container of water, and then we have a sample here. Now we know the mass of the sample, so let's say mx. We know the temperature of the sample, Tx, and we're looking for Cx, the specific heat. And of the water, we know the temperature of the water, we know the mass of the water, and we know the specific heat of water. Now here, as we can see, since this sample we have a higher temperature of the water, heat will be released from the sample into the water. So basically we can calculate the equilibrium temperature that will be reached in the system, and by that we can calculate the specific heat of this sample. Now in our cases, we're going to say that the system is isolated and that there is no heat transfer between the sample and the walls of the container. Otherwise, we have to know the mass of the walls of the container and the material from which the walls are made. Now, in our case, we can say that minus Q of sample is equal to Q of water. Now, what this means is that the heat that's going to be released from the sample will transfer to the water. And here we have minus, since the minus indicates that heat has been released from the sample, and here plus, since we are basically heat is added into the water. Now, if we replace the equations for specific heat into these, we'll get that minus m sample, so minus mx times Cx times T final, the equilibrium temperature, minus Tx, or the temperature of the sample, is equal to the mass of the water times the specific heat of water, which is 4,186 joules per kilograms times degree Celsius, times we have Tf minus T water, so the final temperature or the equilibrium temperature between the sample and the water in the container and the initial temperature of water. Now, since we're looking for Cx, we can modify this equation, and for Cx we'll get the mass of the water times the specific heat of water times the temperature difference over the mass of the substance times, now here we have Tx minus Tf, since here we have a minus, and if I multiply this minus with the values here in the brackets, we'll get Tx minus Tf. And now we have the equation of a calorimeter. So basically we can calculate the specific heat of a certain substance if we insert it into a calorimeter. Now let's solve a problem. As always, I will post the problem down in the description. So let's see. A 0.05 kilogram ingot of metal is heated to 200 degrees Celsius and then dropped into a calorimeter containing 0.4 kilograms of water. which is at 20 degrees Celsius. The final equilibrium temperature of the mixed system is 22.4 degrees Celsius. Find the specific heat of the metal. Okay, now we can use a formula that we studied in order to calculate the solution. So basically, in this formula, we will only replace the values for the temperature difference, the masses, and the specific heat of water. And what we will get is C of the ingot will be equal to what? Now we have the mass of the water, which is 0.4 kilograms, times the specific heat of water times the temperature difference. Now the temperature difference is 22.4 degrees Celsius minus 20 over the mass of the substance, which is 0.05 kilograms, times, here we have 200 degrees Celsius minus 22.4 degrees Celsius. Now, if we calculate this for the specific heat of that substance, you will get that's equal to, let's see, if I calculate, we will get 453. So 453 joules per kilogram times degrees Celsius. So if you look at a table and if we see the values of the specific heat of different substances, we will see that this substance is basically iron. And that's it all for today. The next video we're going to study about latent heat.